Welcome to our today's class. Today we have physics, and the topic for today is rectilinear motion. So we need to understand what rectilinear motion is before we think of solving the question we have on the board. By definition, rectilinear motion is the motion of a particle or an object in a straight path. And we have some basic terminology that are associated with rectilinear motion, such as acceleration, velocity, time, and distance. So under acceleration, we have uniform acceleration and non-uniform acceleration. And uniform acceleration means constant acceleration. And acceleration is defined as the rate of change of velocity with respect to time. So with that in mind, let's look at what the question says. We take into account two things primarily: uniform acceleration and the concept of rectilinear motion. So like I said earlier, uniform acceleration means constant acceleration. That is acceleration that is constant throughout the journey, doesn't change. So with that, let's read the question and see how we can answer that. Question says, an object moves along a straight line with uniform acceleration. Like I said earlier, it stands for constant acceleration. So the velocities at points A, B, and C along the line are 5 meters per second, 10 meters per second, and 20 meters per second. So that means at A, I have 5 meters per second. At B, I have 10 meters per second, and at C, I have 20 meters per second. So if we go further, the question further says, given that line BC is 75 meters, we should find the acceleration of the object. Don't forget, the acceleration is uniform, that means it's constant. So let's try to illustrate this figure with a diagram, according to what the question says. So let's draw so this is our straight line. Let's call the first point A. Let's call any point along the line B, and let's call the last point C. Question says at A, the body passed point A at 5 meters per second. So that means at this point, the body moves at this point at 5 meters per second. At B, it passes B at 10 meters per second. And it passes C at 20 meters per second. So if you read further, they said, given that line BC is 75 meters, that means from B to C, it is 75 meters. The question says we should find the acceleration of the object. Don't forget, the acceleration is uniform, that is constant. So between A and B, if the body starts from A, it accelerated from A to B. So the acceleration is A. The body also accelerated from B to C. The acceleration is also A. It's uniform. It doesn't mean that from A to C, the acceleration is 2A. No, because the question says the acceleration is uniform or constant. So how do we determine the acceleration? Now let's analyze the diagram that we have. Between points A and B, A is the initial velocity and B is the final velocity. Between points B and C, B is the initial velocity and C is the final velocity. Then distance BC is 75 meters, although we don't have distance AB. So if you consider the region BC, it satisfies the condition for the question. It contains initial velocity, final velocity, distance, and acceleration. So I will consider the region BC to find the uniform acceleration. So let's consider the region BC. BC meaning region BC. So my initial velocity there is 10 meters per second. The final velocity is 20 meters per second. The distance x between B and C is 75 meters. And the acceleration, I don't know. So if you look at this data, it satisfies the third equation of motion, which says that v squared is equals to u squared plus 2ax. So if I should impute the values that I have, my v is 20, that becomes 20 squared. My u is 10, that becomes 10 squared plus 2 times a, I don't know, and the distance between B and C is 75. So if I should simplify the expression, 20 squared will give us 400, 10 squared is 100 plus 2 times a is 2a, 2a times 75, that will give us 150a. So to find a, I can collect like terms. So this one implies 150A is equals to 400 minus 100. 150A will give us 300. Therefore, my A is now 300 divided by 150. A will give us 2 meters per second square. That is now the value of the acceleration of the object according to question A. So what does that imply? It simply means that the acceleration between A and B is 2 meters per second square. The acceleration between B and C is also 2 meters per second square. It doesn't mean that the acceleration between A and C is 4, because the question says acceleration is uniform, that means it's constant. So with that, let's go to question B. Question B demands we find the line of AB, which is from here to here. So if we don't learn the length of AB, let's call it x meter. Let's call it x meter. So from this region AB, at A is the initial velocity, at B is the final velocity. The acceleration between A and B is now 2 meters per second. The distance I don't know. With this data, you also satisfy the third equation of motion. At region AB, the initial velocity now is 5 meters per second. The acceleration is 2 meters per second square. The final velocity is 10 meters per second. And the distance becomes our question mark. So the data here also satisfy the third equation of motion, which says that v squared is equals to u squared plus 2ax. So let's fix in our value. V is now 10, here becomes 10 squared. U is 5, 2 times 2, the acceleration is now 2, times the distance x, I don't know. So if I simplify, 10 squared is 100, 5 squared is 25, plus 2 times 2 is 4, times x will give us 4x. So to find our x, we simply collect like terms. This one now implies 4x is now 100 minus 25. That will give us 75. Therefore, my x is now 75 divided by 4. That will give us 18.75 meters. Question C says we should find the time taken to cover line AC. That is from A, the time taken to cover from A to C. We can actually approach this question in two ways. First of all, we can find the time used to cover from A to B and the time used to cover from B to C. That is, if I should consider the time used to cover from A to B, let's call it T1. The time is spent to cover from B to C, let's call it T2. So to do so, if you look at the region AB, I have initial velocity is 5, acceleration is 2, final velocity is 10, then the time I don't know. So if I consider region AB, my initial velocity is 5 meters per second, the final is 10 meters per second, acceleration is 2 meters per second square. The time now, time 1, that is from A to B, I don't know. So this data satisfy first equation of motion that says V is equals to U plus AT. So I'm characterizing it in the regions. My T becomes a T1. So if I fix in my data, I'm having 10 equals to 5 plus 2 T1. So to find T1, I will collect like terms. 2 T1 is simply 10 minus 5, which is 5. Therefore, my T1 is now 5 over 2, which is 2.5 seconds. So it means that the time the body spent from A to B is 2.5 seconds. Let's also find the time spent from B to C. So I will consider region D. Region BC. So at BC, initial velocity is 10 meters per second. The final velocity is 20 meters per second. Acceleration is 2 meters per second square. The time from B to C, let's call it T2, becomes our question mark. The data here also satisfies first equation of motion. We have V is equals to U plus AT2. So let's fix in the value. This one now implies my V is now 20, my U is 10 plus 2T2. My A is 2, acceleration. So if I make T2 the subject formula, I'm having 2T2 equals to 20 minus 10, which is 10. Therefore, my T2 is simply 10 over 2. T2 give us 5 seconds. So the time the body spent from B to C is 5 seconds. So what is now the total time spent from A to C? To do so to get the total time the body spent from A to C, I'm going to have TAC is now TAB plus TBC. That's the time spent from A to B plus the time spent from B to C. So TAC will give us time spent from A to B is 2.5, and the time spent from B to C is 5. If I add up time AC now, give us 7.5 seconds. So please, if you like the video you are watching, please subscribe and turn on your notification button, and also share the video. But additionally, so in addition, I can also find the time spent from A to C in a different approach by considering point A and point C without putting B into consideration this time. So if I should do so, at A, the initial velocity is 5, at C, the final velocity is 20. Then the acceleration from A to C, since it's uniform, is 2, not 4. I'm not adding 2 plus 2, because the acceleration is uniform. So acceleration is simply 2, not 4. It's a constant acceleration. So let's consider region AC in a different approach and see if we're still going to have the same time, 7.5 seconds. At AC, my U is 5 meters per second, my A is 2 meters per second squared, and my V is 20 meters per second. The time from A to C, I don't know. The data also satisfy the first equation of motion, so I have V equals to U plus AT. So my V is 20, my U is 5, my A is 2. The time spent from A to C, I don't know. So if I should make that the subject formula, 2TAC, I'm having 20 minus 5, that will give us 15. Therefore, time AC is simply 15 divided by 2. Time AC will give us 7.5 seconds. So you can see, we use different approach, but the answer remains the same. 7.5 seconds, 7.5 seconds. So it depends on the individual which approach is more suitable for you. So like I said earlier, please help us subscribe, share, and turn on your notification button. Thank you. See you next time.